All right, now we look into the fourth part, 4.1.4, which is the cross product. So the outcome of the multiplication between two vector, it can be two. Just now we look into the dot product. Now we look into the cross product. The way we have to pronounce it is like A cross B. So when we know A cross B, we will get as long as these two vector A and vector B is not zero lah. If it's not if they are not zeros, A cross B will give a vector as an output. Okay, and it can be represented as A cross B equivalent to AB sine theta in the direction of vector normal. So the way of representing cross product, you can use your right hand, your thumb, your pointy finger, and also your middle finger. You separate it as 90 degrees from each other. So it's like you pointing. It's like you make a pistol move, and then you add in middle finger in the 90-degree direction from the pointy finger. Okay. So if you do A cross B, you will get the resultant length, resultant direction in the vector normal to that. So direction of vector normal, which is 90 degrees, 90 degrees from the cross product. Okay, and here we are dealing with the theta, same like dot product, but the theta here is still the angle between A and B. However, now we are not using cos, we are using sin and sine. So I show it to you guys after this, why this is different, and how the cross product will get sin rather than cos. And the property you see here, A cross B is in the perpendicular to the vector A, and A cross B is perpendicular also to the vector B. The resultant of that vector is perpendicular in normal, so that it is in the direction of normal. The property here, if we still you still remember that if A dot B is equivalent to B dot A, because you get scalar, but that's not the case for cross product. A cross B is equivalent to negative B cross A. If A vector A multiply with, in the bracket, distributive law is still the same, where you cross each other. And if multiplication with the scalar, it's the same thing. You multiply the A cross B with the that scalar. Okay, the cross product cannot function between scalar and vector like this, or A dot B cross C, or A dot B dot C cross D equals E. So it cannot function between scalar and vector. So orthogonal vector, also known as perpendicular or normal vector. We have cross A cross B, we get this, A magnitude A multiply with magnitude B sine theta. And then n here, multiplication with n in the direction orthogonal to it, 90 degrees to it. Where the sine theta here is actually 90 degrees. Theta is 90 degrees. So if you click calculator, sine 90 degrees is equivalent to 1. So here, sine 90 degrees is equivalent to 1. Alright, and A and B are orthogonal vector, and cross product of it, A cross B will be the magnitude vector of A multiply with B equivalent, multiply with the vector n, where n is actually the magnitude of unit vector equivalent to 1. And you can use, this is what I meant, you use your right hand, like you make a pistol shape, and then you add the J component here, and this is K and this is I. Okay, so I cross J, you move your finger, the remaining of 4 finger, I to J, and the thumb is pointing at the K area as shown in here. Okay, alright, and I think I mentioned during the class here, if you can't remember and can't relate to the right hand rule, you can use this. Let me change color. You can use this notation. I to J, J to K, K to I. If I cross J, you will get vector K. I cross J, you get K. K cross I, K cross I, you get vector J. Okay. J to K, J cross K, you get J cross K, you get I. Similarly, if you do it in the opposite way, for example, like let me change color. Okay, you do it this way. J cross I, J cross I, J cross I, you get this direction, negative K. Okay, I cross K, I cross K, I cross K, you get negative J, and so on. So instead of you memorizing things, look at this loop, I, J, and K. If it's very easy. J cross I, you get in this direction. So meaning that it's opposite direction, you add negative. I cross K, you get negative J. J cross I, J cross I, you will get negative K. So it's different than A, I, and J. So you cannot, it's not like A dot product. A dot B is equivalent to B dot A. No, doesn't mean that. It is opposite actually, as shown in here. Okay. Alright. Parallel vector. If we have a cross product, A cross B sin theta, and the vector are parallel to each other, you will get A cross B equivalent to 0 because the theta now is the angle between A and B. So you imagine that you have this vector A and then this is vector B. They are parallel to each other. Let me erase this one. The vector, the angle here is between A and B. Okay, so the theta here, it could be 0 degree or it could be 180 degrees or pi. So the cross product of two similar vector, A cross A, will be 0, or the cross product A cross B equivalent to 0 if the theta is, if the vector is parallel, which is the angle between A and B is equivalent to 0 or 180 degrees. Because if you click calculator, sin 0, you will get 0. Sin 180 degrees, you will get 0 as well. Okay. Alright, cross product of two parallel unit vector will be 0. So having said that, if you cross product with its own direction, I cross I cross I, they are parallel with each other because this is I, this is J, and this is K. I cross I in the same direction, you will get 0. J cross J equivalent to 0. K cross K equivalent to 0. Whereas when you do the dot product just now, I dot I is equivalent to 1, and J dot J is equivalent to 1, and then K dot K is equivalent to 1. So cross product coordinate. If let's say we have two vector. A is vector, the first one, A1. A is actually A1I, A2J, and A3K. And vector B is actually B1, B2, and B3. Okay, so we can find A cross K by computing the determinant. I hope you still remember. You learn in the metric. If you maybe form standard, not standard. What do you call A level, or perhaps foundation, or perhaps SPM. You learn that, but you learn only 2 times 2. You find determinant. What you need to do, you multiply these two, which is AD minus this one, multiplication of B and C. Same concept with this. Now we have the 3 dimensional, I, J, and K. Component X is component A is A1, A2, and A3. B1 is B2, B3. You find determinant. First determinant, you close this part. First determinant for I, you close this part. So you only handle this one. So it will be A2 times B3 minus A3 B2 for I. And then for J, it must be negative J. Negative J. This is determinant formula. Here, let me change color. here, and this diamond, it must be negative, 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 negative. That's why negative here. Look back at the formula. In order for you to determine the determinant of 3 times 3, this diamond is in the shape of diamond. Here must be negative, and also determinant can be determined whether through row or through column. And J here, I let me change color. J here, you cross this one and close this one, so remain this one and this one. So for the J part will be A1 B3 minus A3 B1. And then plus K part will be, now K will be this one. Cannot see. K will be this part. So leave it with A1 B2 minus A2 B1. Okay, that's how you get this one. So this is how you get this one. Determinant of 3 times 3. You can also Google on internet. There's a lot of YouTube video on how to find determinant of matrix 3 times 3. Determinant of matrix 3 times 3. Okay. Alright. Now, let's look into the projection of a vector. In the dot product, you will see that the projection of the vector is in projection is in the y direction instead of the x direction. Just now, I mentioned that the projection here onto this plane, on x direction, onto this plane, this is projection in terms of the I direction. And I said that, if you remember, I said that if you put torchlight here, we put the torchlight on this direction, and this vector will be pointing here. However, if let's say we have torchlight in this direction, we project into y direction now, in j direction now. So we have the orthogonal part, which is the NM here. Projection, previously we learned that if we use dot product, we will get beta cos theta. However, now we extend the projection into j direction. Now the light coming from here, we project this into here. At the j direction, you only see the one straight line projection from here. So J and I is actually perpendicular with each other. So B dot J is the unit vector. So Bj, the unit vector, and the magnitude of unit vector is 1. That's why we get B sin theta. It's like this. If I can recall, this is I, this is J, this is O, this is M. So if you want to find at this direction, you find sin theta J over I, right? So here is actually I sin theta, or vector B in this case, because of the projection of that. Okay, so in order for us to find the NM, and M is actually B sin theta in the direction of J. So we do cross product B cross I. It is BI sin theta in the direction of N. Okay. Alright, so it indicates that if we do dot product, the distance from N to point M can be found in the dot product, and also we can use cross product. If it's dot product, B dot unit vector J. So meaning that J divided by J lah. You still get the vector. However, you can straight away do the cross product, B cross I unit vector S in here. So when you know the concept of A and B, the theta is between the vector A and B, you can use to determine the area of parallelogram. The area of parallelogram is shown in here, and A and B here. A can be represented as here and B can be represented as here. This is the same length and also same direction because they are parallel to each other. So A cross B, you can multiply it together where magnitude A multiply with magnitude B and sine theta because you are determining at this direction. And the relationship here, A cross B sine theta, you get the vector normal here. And this is the area of parallelogram. So area of parallelogram can be determined by A cross B, the magnitude of it. And if you want to find the triangle at here, it will be half multiply with the height of parallelogram plus the length. Multiply with the length. So it will be half of A cross B. Okay. Alright, let's look into 4.15 application of cross product in geometry given a parallel vector here. Previous dot product application are used mainly when the normal vector is given. When the parallel vector is given, we can use the cross product to find the 3D line equation between intersecting plane, distance between point to 3D line, and distance between two 3D parallel line and distance between two 3D skew line. So in the Cartesian format, we need to find the Cartesian equation of the line passing through any given point, and there is a normal vector to that. However, if it's the problem in 3D line, the parametric equation where the two planes are intersecting with each other, this one, one plane and another plane, they are intersecting with each other, and we can find the normal vector of each plane as given in that. And then we can also find the shortest distance from point to line. Same thing, we can find the distance between a point to the plane and the distance between two parallel point, or distance between two parallel 3D two parallel plane here. Okay, and find constant distance between two skew line that is not exist, or two skew line that is exist, meaning that skew line meaning that the two plane are parallel with each other, but the line are not parallel to each other. Two plane parallel, and then the two lines are not parallel. Okay. Alright. Let's look into the parametric equation of 3D line. If let's say we have two planes that intersecting between each other, and the normal of that plane given as n1 and n2, meaning that n1 is the normal vector for the plane s1, and n2 is the normal vector of plane s2. L is both normal n1 and n2, so L is actually parallel to the cross product of these two vectors, n1 cross n2. Let P be any point on the line and the vector equation of that L is given by vector OP plus T n1 cross n2. Okay, so let's look at this example. Find the parametric equation of the intersecting line of the plane S1, 3x minus 6y minus 2z equivalent to 50, and another plane is 2x plus y minus 2z equivalent to 5. Alright, so now the question asks this, find the parametric equation first. Parametric equation. Okay, parametric equation of that of the intersecting line. Intersecting line. Okay. Now we find the we find the n for this one first. N1 and N2. N1 and N2. So the normal for this plane is actually N1 is actually 3 I negative 6j and negative 2k. Where I get this from here. This is the equation of line. Equation of the plane. So the n1, the normal to that, you just take the component of x, y, and z here. And the vector n2 will be 2, 1, negative 2. Okay. Alright. So you already determined the n1 and n2. now we calculate the direction vector of the line L. So we do cross product N1 cross N2. So you get this is I, J, and K. You do dot product 3, negative 6, cross product negative 2, 2, 1, negative 2. And you find determinant of this. So when you find the determinant of this, you calculate it first, you will get that the cross product of it will be 14, 2, and 15. You try on your own to find the cross product. So you will get this one. And then, alright. So we need a point at point L, at line L. To find this point, we can set the variable z equivalent to 0. Z equivalent to 0. Okay. And when z equivalent to 0, solving, we solve for x and y. Okay, we can find that the equation is x equivalent to 3, y equivalent to negative 1. So the point at point in line will be 3, negative 1, 0. So the parametric equation here, if z is 0, you can find this value. So you just replace the value of z here. So we can do this exercise. I mean, we can discuss it when we meet face to face. So you do the parametric equation of that. You will get x equivalent 3 plus direction vector is 14t, and y equivalent, I got no space, I put it here. Y equivalent to negative 1 plus 2t, and z equivalent to 15t. Okay. Alright. So the rest of the example we discuss in the class. You can try it first. And then we can also calculate distance of point to the 3D line. As I mentioned, we want to do the projection at the J direction now, as the Y direction now. So let L be a line passing through a point P with vector R equivalent P plus TV, where T is an integer. So by using the projection method, we can find the PQ cross V here, and we can get PQ cross V equivalent to PQ sin theta. That is distance between point to the 3D line. How about we want to find the two parallel 3D line? The line is parallel with each other. Let's say the first line is A1 TU, and then line T is B plus SB. So by using projection method and cross method, we can know the distance of point Q to the line L, which is PQ sin theta, or PQ in the direction of unit vector V. So it can pick either way. Either you take U or you take V. Doesn't matter, because they are parallel. You will get the same answer. Okay. And distance between two 3D skew lines. Skew line meaning that they have two planes that are parallel to each other, but then again, the line are not parallel to each other. Okay. So we can, L1 is, let's say L1 is in parallel with vector V. Then the normal vector is, we calculate by U cross V. And the vector P to Q is parallel with vector normal. Vector normal, in order for us to find the vector normal, we cross product vector U in the line 1 and vector B in line 2. Okay. Therefore, the shortest distance between L1 and L2 is actually AB, where AB is equivalent to vector normal, dot product vector normal divided by its magnitude. Okay. Alright. This one, the exercise, we can discuss later when we meet face to face. Okay. Use of scalar. Last topic on the vector algebra here is the use of scalar triple product. The scalar triple product, you can use it to calculate parallelepiped, where this is the shape where we can conduct the cross product of vector A and B, and then we dot product with vector C. Area of the base here is actually the cross product of vector A and vector B, and then here is actually vector C cos theta. C cos theta. Okay, so this means that the base area times the height and times the height, you will get the volume of the parallelipad. And the projecting area, if you want to calculate the projecting area into one plane, we can do A cross B like this, A cross B onto the plane N, which is a normal unit N. So you can do cross product PA dot PB and PA cross PB, and you get the answer as shown in here. And after that, you can dot product with vector N. When you dot product with the N is you get I dot I plus J. So you get the answer is 5. Alright. This engineering application we will cover in the next week. Thank you.